Hello? Okay. So welcome to the workshop called How Does It Work? The Packaging Software in Fedora. This is a new version of the same workshop that I did a couple of years ago, I think in 2015. Well, you have seen this slide already, so I will just skip it. For the agenda, we'll start with a quick example, which is also documented on Fedora wiki, and then we'll do a short introduction to packaging, which I'll go over the main points only because, as I asked the audience before, most of you have already tried building a package at least once, and then there are two exercises. Or if someone in the audience has a package to create, we can do that instead. This is the Fedora website for developers. You can find resources related to packaging from there, or you can go to Fedora wiki and there is documentation there as well. These are the basic steps to create the example package that I will be talking about in a moment. You install a couple of packages with packaging tools. The second command creates an environment in your home directory for creating packages. But basically just a directory tree, and then you can download the sources. We will be packaging the new Hello package, Hello software, which all it does is just say hello, but in a very proper way, handling errors, detecting stuff, and so on. Like an overcomplicated, simple thing, but it makes for a good example. Then the last command generates spec file template. This is what you can use. I'm not sure how current the spec file template is these days, but never mind. I will show you how it should look in the following slides. So let's start with what we call metadata, which is the preamble containing name, version. The release field means the revision of your package itself, not the revision of the software that you're packaging. So whenever you make changes to your spec file, you increase the release field. When there is a new version, you reset the release field to 1. Unless it's a pre-release, then it's a different story. Let's stick with a simple example. There should be a very short one-line summary. You put in the license. This is important to pay attention to. I will talk about it a bit more later. The URL for the software you're packaging, which usually points to the project website, and source URL. There may be more than one. And if there is a requirement to patch things, we also put patch number lines in the preamble. The description field is also not optional, and it should be a little bit more elaborate than the summary, but this is left to packager discretion. And the last thing from the metadata is the changelog, where you document the changes you make to each revision of your spec file. There are ideas to make it automatically generated from a Git commit history, but it's not implemented yet, and there is no consensus on how to do it, or even if we should do it. So for now we are stuck with a bit of redundancy. And this is how the real meat work looks like, meaning the actual steps at the time executed to build a package. The prep section, well, all you can see here is just the one macro. All things prefixed with a percent are macros, RPM macros. So what it does, it unpacks the sources declared in the preamble and applies any patches that are declared as well. So it's like all-in-one thing. In the previous version of this presentation, there was setup-q, but nowadays auto setup is recommended. Of course, the old one also works. So if you just have one source file and no patches, then you can also use setup. And this is for this simple example. So in the build section, we execute the steps that are required to compile the sources into binaries. If this is the kind of software we are packaging. So configure macro executes the typical AutoTools based configure script with all the required options mandated by Fedora policies, and make build executes make, adding parameter to run it to use parallel compilation depending on the number of processor cores you have on the system where you're building it. So this is done automatically by the macro. In the previous version we had make and dash, some more complicated macro name, but right now it's just one simple macro. And install section, as you can see, runs make install, and this is also a macro that specifies a build root destination, because when we are running, of course, you don't build packages as root, so when you run make install, you have to tell it where to put the files, because you cannot install to root, you don't have privileges, right? And there are two other things that are being done here in the install section. Second one is generating a list of language-specific files, translations, gettext translations in this case. And this is also used later, because the find lang macro generates, well, you specify the part of the file name, and it generates a file called this.lang in the build root, so you can easily include it in your files section, and not worry about any, let's say, changes in translations. If there are new translations or some dropped, you don't have to worry about it. It will get handled automatically. And last thing is just for not making RPM complain about some files in the build root which we are not packaging. So we either remove them in the install section, or we use exclude macro in the files section to tell RPM which files should not be included. You can use whatever method you like. Both are equally acceptable. And finally, the files section. Here you declare all the files that you want to end up in the final binary package. I call it like a snapshot of the installed state. You can also build the package apart from building it from your regular shell and just running RPM build. You can run it in the same environment that Fedora does package builds, which is mock. And these are the steps to install mock and configure it for your user. And then you pass a source RPM package, which is just spec file and the source tarball and patches, whatever, and files needed packaged into one convenient file. You pass it to mock, and it should build a binary package in a environment specified with the -r option. There are pre-configured definitions for all Fedora versions, and also Red Hat 6 and Red Hat 7 compatible, because Fedora provides repositories for those that are called EPO. So, this was the quick example. I hope it was clear. If you have any questions, feel free to interrupt me.
Yeah. Why are sections and macros not really visually different? You don't really see what's... does install do anything besides calling the macros below?
So the question was how do sections differ from macros? Well, the answer is they don't. You can even create a macro that generates a whole section and not put the section name in the spec file. Funny things may happen if you use the macro and also type the section name and something there. So yeah, there is no difference. There are some macros. Yes.
So, can you go back a few slides where you are doing the setup of the...
Here?
No, above. Yes, this thing.
Right.
So, whenever I'm working on Fedora packages, I have a single directory with the specs, the sources, the patches, and this split between multiple directories. Well, this is something that you shouldn't really do anymore, right?
Yeah, you don't have to do this. This is just the default configuration.
Yeah, but it's useless. So.
Well, yeah, if you are a Fedora packager, you often work with a Git clone of your packages Git repository from Fedora, and you do all the stuff inside that single directory. But well, this is for people who are not yet Fedora maintainers.
So an alternative workflow is that you create a directory, cd into this directory, type git init, and then create the spec file there. And to allow Fedora package commands to work with this directory without really having a package in Fedora, you add a fake git origin, and then everything works. You can say fed package build, and it works. Don't need to mess with RPM commands directly.
So Zbyszek has a very good idea to use Fedora tools from the beginning, and just work in a single directory and record all changes using Git. So yeah, I will include that in the next revision of this workshop. Thank you very much.
But a related question, won't I have a problem with sources? Because at least some time ago, I could have spec file in the Git repository for Fedora packages, but RPM Git wanted sources in data-defined folder. So I need to reconfigure it to use current directory on some other for binaries.
Okay, so the question is, normally RPM build complains about sources not being in a specific directory, and how does it work with using one folder. So Zbyszek mentioned fedpkg command, the tool, which actually overrides default RPM build configuration. You can also override it using .rpm macros file in your home directory. It just specifies what path it should use to look for sources, to look for spec files, to use as build root. Yeah, those locations are overridable by the user. You can either specify them yourself or use the tool that will do that for you automatically. So, yes.
Okay.
Not a real problem. It's just that by default it does that, and it uses that directory structure. You're welcome to send a pull request to change the defaults. I'm not sure it will be accepted, but it's worth a try. Let's go back and actually let's go forward. remind ourselves what a package is for the audience who will be watching this on the internet. So a package consists of two main things. First one is content, meaning files that are included in the archive. And usually it's compiled code, sometimes it's code that will be interpreted, but it can also be just data or configuration files. And this is what gets deployed on the file system, right? Second part is metadata, which is used by package management tools to do things with the package, like resolve dependencies, answer administrator queries or some automated queries, and sometimes you need to do other things apart from just dumping files on the file system. So there is support for scriptlets, as we call them in Fedora. They are in RPM. They are run by Bash by default, but you can change the interpreter. And there's also LUA scripting language available, even when the Bash is not, and the Bash shell is not installed. And some of the most interesting macros nowadays are written in LUA. So why do we even bother creating packages? Well, it's a good idea to package everything you want to install on a Red Hat or Fedora or compatible Linux distribution, or actually on any modern Linux distribution in general. So there are a number of things that are important. One is the ease of management, because there are tools which let you manage single packages, groups of packages, and what follows is that we need some sort of dependency tracking, and RPM packages, also other packaging management systems like DPKG give us that. So whenever you want to install one package that has dependencies, the automated tools will pull all the dependencies for you. So that makes your life easier these days. I'm not sure how many of you remember the old days where you would download a random RPM package from the internet, try to install it, and find that it requires this and that and one another RPM package, and you went back and looked for those, and this process was iterative. So sometimes it took many tries to install one RPM package, because there were no tools like DMF, Yum, Zipper, apt, whatever. Next thing is querying. So you can query for names, versions, licenses, change logs, descriptions. You can ask the RPM database what package provides a certain library, or one of the most important things, which package does a particular file belong to, or which files come with this and that package. So this is like a basic tool for administration. You can verify if a package is completely installed, if any files have been modified, and also I don't know if it's RPM specific or not. I guess DPKG has similar level of metadata. You can see which files are config files for a particular package and which files are documentation, but they have to be marked in the metadata as such. This all depends on the package maintainer or a script that or some other tool that generates it automatically. But the feature is there and it's useful, because config files can be modified from the default state, right? And we want to know. And last but not least, reproducibility. I know Debian has been doing a lot of work in that area to get reproducible package builds. I mean, completely reproducible bit for bit. Fedora is not there yet, but at least we get the same binaries, assuming they don't get timestamps inside during compilation. If you have the same versions of libraries in the build system, then you should get the same binaries. That's the idea. So what are the best practices when creating packages? Those of you who attended my talk on Friday should already know this slide, but let me repeat it. One of the most important things is explicit file ownership. So all files that are dumped onto the file system by a package, and possibly all the files that are created at runtime, and we care that they should be deleted when package gets uninstalled. They should be all declared in the metadata, so that RPM can manage them. We should avoid bundling. This was the stance on this was much stricter in the past in Fedora. It is a bit more relaxed these days. We allow bundling, but still require any bundled libraries, projects to be declared in the metadata so that they can be queried. Again, querying, a very important feature. What follows is that you don't bundle, you use shared libraries that are available in the distribution already. If your package is not completely compatible with the one we have, you are either try to work with upstream to fix it, or maybe you can introduce a compatibility package with an older or newer version of a library into the distribution to fix this. Maybe there are other packages who can make use of this version. It all depends on a particular case. Another thing is that all RPM installations must be non-interactive. I highlighted that in my previous talk, that sometimes packages try to ask installing user some things interactively during installation, and this might not work because there may be no user when the package is installed, or there may not even be a terminal in which the display works. This happens during automated installs. When you install the system for the first time, for example, this can happen, so we cannot depend on any interactivity. Also, scripts that shouldn't fail hard. They can soft fail, but they should not stop package installation. And for some of the scripts, I think this is handled automatically. Just execute is ignored. The package should be buildable by an unprivileged user. So building as root is a big no-no, because if you make a mistake, you can wipe out your system when you build as root, right? And the package should be integrated well with the rest of the distribution. This means following the chosen defaults for the distribution, chosen, let's say, I mentioned a firewall management system before. So Fedora uses firewall D. Your package has support for several firewall management systems. Firewall D should be installed by default. Of course, you can sub-packages, for example, for other, like plain IP tables or whatever else. And the package build should be reproducible, so you should declare, for example, you should declare all your dependencies explicitly, and if any are automatically detected during compilation, they should be disabled explicitly, so that when someone installs something extra in the build root, that you don't get a different build just because that extra feature is automatically detected, but not specified in the build requirements. Now, what is specific to Fedora? Because everything I said up to this moment applies to all package management, regardless of whether this is for RPM or DPKG or any others. Now, when you want to include a package in Fedora, there are quite a few things to consider apart from packaging best practices. illegal for Fedora to distribute this software, which means because we are supported by Red Hat in terms of legal matters, so we are bound by US law regarding distributing stuff, and some things cannot be distributed yet. But this is changing as patents keep expiring. So right now we have MP3 in Fedora, MP3 support. We have AAC support coming because there is a free implementation that is not patent encumbered. Second thing, that Fedora has specific requirements for naming and specifying versions, because upstreams have sometimes very strange versioning schemes, so we try to give it some order. But Debian has also similar rules. Next thing is the package must, or at least should, build on all primary architectures and work correctly, assuming it's not some architecture-specific tool. If it doesn't, then you may add some. You may exclude this architecture, but you should open a bug and so that it is tracked. You have to apply the default compiler flags that are specified in Fedora. If you can't, then of course there should be a good reason. But well, our guidelines are something that you should try to follow as much as possible. But if there is a good reason not to, then you just document it and do your own thing, and try to go back to compliance later. If there are any patches that you have to apply so that it works better on Fedora or compiles at all, because Fedora tends to have the newest GCC version. Sometimes older software breaks when compiling with new GCC. So very often you have to patch it, and consistent with the friends value of Fedora, we are encouraged to send all our patches upstream. So it's also relieving of our burden as maintainers. You don't want to maintain hundreds of patches inside your package. It's better when those patches are accepted upstream and you don't have to patch downstream. And there are many more guidelines, too many to mention during such a short presentation. So there will be a link later where you can find all of them. Of course, you don't have to read all of them, just those which are relevant to your particular package. So how does package end up in Fedora? Well, first you have to have the code, any patches that you need, or other files, spec file, and this gets built into an RPM file. You submit spec file and the source RPM file for review via Red Hat Mozilla. For the moment, though, there is talk about having a separate tool for that, but nothing materialized yet. The package gets reviewed by another package maintainer. This not so easy to find reviewers, but there are a couple guys who are very active recently, so your chances are quite good right now. If after a week or two your package is still not reviewed, then you're welcome to ask on IRC or on a Fedora mailing list. Someone should notice that and do a review. Once the review is accepted, the package is approved, and you well, I seem to be missing a step there. You request a Git repository using a fedpkg command. Yeah, it's now integrated into the same tool. So you request the Git repository. Someone from the infra team reviews, if your package review is really approved and then the repository gets created, then you commit your spec file, any patches. So like Zbyszek mentioned before, if you did it using FatPKG before, and you just change the git remote to proper URL for your packages repository on Fedora infrastructure and just git push. That's it. And you request a build. Again, you can do it using FatPKG tool. And once the build completes, you can make a release. This means submitting it into as part of Fedora called Body, which is a tool to manage package releases for new packages and for updated packages. And usually a package has to either be tested and feedback given by a couple of testers, and then it gets pushed to stable repositories. But if you don't get too many testers, that might be difficult. So it has to, let's say, sit for at least 7 days in the testing repository, and then you can push it to stable. And that's in short how it looks for new packages and for updated packages in Fedora.
So I think you
Can I miss anything?
The sponsorship step, no?
Right. So at the time of review, thank you, Zbyszek mentioned that you need a sponsor when, and you do need a sponsor when you are not a package maintainer in Fedora yet. This doesn't have to be the same person as the reviewer, so someone might review a package, someone else might sponsor you. By sponsoring, I mean just approving your membership into the package maintainers group.
But probably also be a mentor for you. That's the main.
Yeah, the idea is that the sponsor is your mentor and answers your questions regarding packaging, gives you tips and pointers, and generally takes care of you for the beginning of the process. Well, if anyone is interested, I am a sponsor, so you're welcome to submit your package and let me know. So I will review and sponsor you, or we can get someone else to review and I will just sponsor you. All right. Any other questions here? No. So quick summary: package is content and metadata. We create packages to, well, in short, automate, make our lives easier in general. And best practices, if I had to sum up, would be no surprises, which means reproducibility, non-interactivity, and so on. There are specific guidelines in Fedora. All distributions have their specific guidelines. Most of them are quite similar, so once you start creating packages for one distribution, it shouldn't be that much of a stretch to do the same for others. And we did a quick review of the package lifecycle in Fedora. So there were questions during my presentation, so if you have any additional ones, feel free to ask. There are some links. I will of course provide the presentation to the organizers, so the links are clickable, but you can also find them via internet search. And yeah, we can start doing exercises if you are interested, or if anyone has a specific thing that they would want to package, we can do that instead. Any takers? Any proposals for a package to create?
Didn't you have a package one?
It's still work in progress. I don't think that we can finalize it here.
The software is work in progress or the package is work in progress?
Package. I mean, it's packaged for our own channel, and I made some effort actually to attempt to package it to Fedora, but at the end of the day I had no time to finalize it. So it's like work in progress to change my spec in order to follow the guidelines.
Okay, so Piotr has a package which he feels is not ready for submitting to Fedora yet. But is it long and complicated or short and simple?
Rather complicated. So
Okay.
I got one Python 3 application, but probably it currently doesn't work because it's work in progress. Probably.
Maciek has a package that you have software that is not free software.
It's Python 3.7, and recently it stopped working because of some dependency problems. So, not sure. It's my own, so, and I thought about packaging it in the future. Not sure.
Yeah, well, there are specific guidelines for Python packages, and there are macros. I can show you how a simple Python package spec file looks. So you can see how simple it is nowadays. Let's try. This should be simple.
We don't see any.
Yeah, one second. Let's open it in something graphical so that yeah, you can see it because I haven't cloned my desktop. This. Fine. Is that visible? Should make it better. Okay. Let's keep this configuration. This should be better.
It's fine.
Now we can also try to focus. No, it's not that. So, because it in Fedora until Fedora 30 we used to build packages for both Python 2 and Python 3. We have to do a bit of macro work, and that's why I'm factorizing the description, because it's going to be the same for both Python 2 and Python 3 packages. That's why you see this percent global is a declaration of a macro. Down there, if we go down, well, you see the main package is called Python MLTL, but it won't contain any files in the end. What is interesting, the Python 2 and Python 3 sub-packages. As you can see, they have different. Oh, it's just more convenient to have the build requires in sub-packages. They apply to the whole package, in fact, but it's easier to have them grouped under each sub-package. Because when you remove a sub-package, you can remove the build dependencies at the same time. And this is what's actually happening in Fedora 30. We are removing Python 2 packages.
How to specify Python version? I mean, is the general 3 version, if it's about 3.5 or 7 or whatever?
Yeah, well, in Fedora we have one main Python. We have one Python 2 version, Python 2.7 the latest. And in Fedora 30 we won't have it anymore, or at least in a very limited fashion. You are right about Python 3 in general. There are multiple versions, but again, in Fedora we have just one. There are packages with Python 3.4 and 3.2, but they are only they are targeted only for testing your code with this particular Python version. So it's just the main Python a project package without any modules. So yeah, all the modules packaged in Fedora are built for a particular Python 3 version that is currently in Fedora. So it's Python 3.6 right now. I think 3.7 is going to be in Fedora 30.
About Python 2, it is or it is just a plan because it was planned to remove Fedora Python 2 in some previous versions, and there are still some dependencies, some projects which still depends.
Yeah. So the question was what about Python 2 in Fedora? As I mentioned, we are in the process of removing Python 2 packages from Fedora. The change is targeted for Fedora 30, which is the next release, going in half a year. And this is already happening. There are a couple of people working on this, and they are checking which packages in Fedora are leaf packages, and removing those first. Well, the idea is to trim down Python to ecosystem to be as small as possible, because Python 2 will basically be unmaintained starting right now, at least in Fedora. So it makes sense to get rid of Python 2 packages as much as possible.
So there is a hope to have it in Fedora 30. I mean, to don't have. There is a hope to maybe have it removed in Fedora 30.
Yeah, I think it will take at least one or two more releases to have it removed completely, because I know personally of some packages that do not support Python 3 yet, or are in the process of moving, but it's not completed yet. But yeah, this is happening. So yeah, I wanted to show you the build and install sections because they are very simple for Python packages. There are macros. Yeah, you could close them. So for building a typical setup tools package, you just run one macro and it gets built with all the correct options required by Fedora. Same for installation. And the check section is for running tests or verifying the package is installed correctly. It depends on which test framework the package is using, so it's not so nicely handled with one macro, but and the file sections are also quite short. If it's just a library or a module, in case of Python, you just use a macro for the library location and name and Python version. So whenever Fedora changes Python version from 3.6 to 3.7, a simple rebuild makes it Python 3.7 compatible, assuming that upstream supports Python 3.7. Yeah, they usually do. Is anyone trying to make a package from the project I mentioned in my slide? It's a game. It's in fact it's a Worms clone, but it's free. And it should be easy to package, so that's why I chose it. So you can play it afterwards as a reward. And the spec file should be really simple. And if you have any issues, let me know. I will go over and help you. Or if you have any issues with your own package and you would like to have them resolved right now, it is also a good time.
I see it's a project based on CMake, not on AutoTools. So is there a different macro for this?
Yes, there is. And if you go to Fedora packaging guidelines, you will see there are specific symlink guidelines, if I remember correctly. But yeah, okay, let me show you the spec file.
So, and what about this? The sources, can they be, should they always be tar GZ or?
No, they can be anything. It's just that for tarballs or zip files, there is built-in support to unpack them. But it's not. I mean, you can unpack them on your own, and there's a setup macro to create the build directory, and that's it. For example, if you just want to create the directory and not unpack the sources, then you use create directory is C, and the not unpack is capital T. So this would create the default, which is name dash version inside your defined build root, and change to it. And then, for example, you could do R and S. This is short for. I mean, you could also use source 0 as macro, but this is just shorter. So I've been using this for quite some time, ever since I discovered it. So, yeah, I don't claim to know all the tricks of our RPM packaging, although I do have over 10 years of experience. And I still learn things every day, because there are very talented guys who write convenience macros. For example, there's this guy called Nicolas Meichelt, who attempts to make it very easy to package software projects that follow certain pattern, like being hosted on GitHub or SourceForge or another, what he calls Forge. And you just specify a couple of things, use a macro to generate the rest of the spec file. So it makes it very easy. Let me show you an example, because I had to package quite a few Golang projects recently. So let me show you a simple Go package. For example, this one. So, main thing you specify is Go include path, because with Go you just the idea is to go over the internet and fetch things directly from GitHub, for example. In this case, you need a description, of course, and a version. And you just call one macro. It does a lot of magic behind the scenes. I don't even know how it works. You need a double package for because other, in this case, other Go packages use this library, so they need a double package, and it's generated almost automatically. Yeah, there's a very simple build section and very simple install section.
So I have another general question. So we have from the first slide we do the steps which create this directory structure with source, spec, and so on. And so should we run some commands to test if the spec file really is able to build a package? Because well, how do we do the iterative process of getting the spec file right?
Okay, so the question was how to test your spec file and get feedback on what's wrong. What I do usually is use mock, so that I don't have to install all the build dependencies onto my regular environment.
That was the other slide, okay.
Yeah, that was the other slide, how to configure mock for your own. And also this is good for developing packages for Fedora, because Fedora also uses mock underneath their build system. And you try to build the package. Actually, you can enter the mock environment using mock shell command. Of course, you have to specify which environment you want to enter. So mock-r Fedora, let's say 29, x86, 64. Actually, let me show you. Change. I have one pre-configured just for presentations, so you can use mock -r, say Fedora. Actually, let's do that. Let's break the spec file and. Thank you. Let's use the game as an example. So let's, for example, forget to specify some dependencies. Let's build the source package. It worked. So let's build on Fedora. Yeah, 29. Let's try this. It should fail, of course. So what mock does is it installs the minimal set of packages required for having a build root. They are defined in a configuration file, and if we can see that there are some updates in the meantime. Fedora 29 has just been released, so it's expected that there will be some more updates in the beginning. And then second phase is installing build dependencies, which is what we declare in the spec file as build requires. So I specified SDL and boost and some other things, but I forgot to specify GCC or G++, which is required to be done explicitly nowadays. It used to be that we had GCC by default in the build root, but not anymore, because there are a lot of software projects that don't require GCC for building, so it makes sense to make their builds much faster, because installing GCC brings quite a few packages along with it. So, yeah. Thankfully, the internet connection here is quite good, so it doesn't take a lot of time. Install the build root. There's something else required GCC, so my trick didn't quite work. But I think at least one of the things I commented out is not pulled in by other. Yeah. So as you can see, configure failed because libconfig++ is missing. So what I do is run the same command but with the shell and change to the mock build user. And actually I open the file directly, change the color profile so that you can see better. So I can edit the file directly. It's under varlib mock, and root is like the ch root. Build here, and everything is here. So because it uses the same default folder structure. Oh, for automated builds, it doesn't matter. It doesn't have to be so pretty. It just works. So actually, I don't need GCC C++, but I do need this. Yeah. And now we could try doing the same thing that mock does. Trans RPM build, of course, building the scene. And it will fail because it's not installed. So let's get out of the mock shell and install. So you can install packages manually into the build root. And we need, let's copy and paste. And let's try again. And it looks like we actually need GCC C++ after all, because it doesn't detect it. It just fails when trying to run it. Alright, no problem. Let's add it. C++. Okay. And this is the iterative process you were asking about. Let's see if it works. We will have to ask the organizers to provide a pod for the microphone next time. Okay. And run RPM build again and see whether. As you can see, there was a warning about missing image magic. But the configure didn't fail. So, well, this is why you have mock logs, so that you can review them later and see if you missed anything that wasn't strictly required, but would be useful to have. And as you can see, because my machine has 4 cores, and as you can see in the CPU monitor, its compilation process is using all of them. That's because the make build macro automatically detects a number of cores and uses all of them by passing -j and a number to the build. Actually, as you can see, it built successfully, and we can try installing it. There are 2 ways to do it. You can install the freshly built packages automatically by mock using --post install, but you can also pass the path to the with a prefix. And this. We can test if the package is installable, which is one of the things you should test before submitting it for review in Fedora. And as you can see, it not only builds correctly, it can also install correctly, which is a good thing. Which means we can actually try installing it on my own system. So let's do this. Okay. no new dependencies required, so just the package and you can run it. And yeah, it works.
Nice. Partita, tak? Znowu się...
This is computer versus computer. So. This is what you should get after packaging and building. Okay, that's what I have for today. Any questions?